Hello students, welcome back to maths class. Come to our interesting topic, integrals. So yesterday you got the definition and some problems of integrals, right? So today also we will solve some problems, right? From exercise 6a we will solve some problems, okay? So first take the first question. So we are applying the formulae slowly in our problems. Take the first question. Find the integral of x plus 4 by 1 plus x square dx. What is that? Integral x plus 4 by 1 plus x square into dx. So what I said? First observe the problem. If two terms are there, three terms are there and plus minus signs are there in between them, then you take the separate integrals. So you take the separate, here x term is first term, after that we are having plus. So in between two terms we are having plus sign, means we have to take separate integrals now. So integral x dx plus integral 4 by 1 plus x square dx. So whenever constant is there with the function, I said take the constant outside and observe here x means we can take x to the power of 1. That is, which form it is? Whenever we are having for x power is there, most repeated formula integral x to the power of n dx is equal to, I said, x to the power of n plus 1 by n plus 1. So come on, here we can take x to the power of, in n place we are having 1. So 1 plus 1 by 1 plus 1. And take your 4 outside, it is number, numbers are constants, we can write outside 1 by 1 plus x square dx. This is also most repeated formula in our integration. Integral 1 by 1 plus x square dx is the tan inverse x. So x square by 2 plus 4 tan inverse x plus c. After the completion of the problem, we have to write plus c. That is most important. Suppose after writing all these things, you forgot to write this c, means you will lose the marks. Compulsory integration means integral constant must be there at the end of the answer. Remember this point, plus c we have to write for all the problems. Now come to the second one, find. So sometimes the problem will be directly in your standard formulae form. Sometimes we have to reduce the problem into our standard form. 1 minus x square plus 2 by root of 1 plus x square into dx. Again observe, one term is there plus another term is there. Inside the integral, if we are having plus minus sign, we have to take separate integrals. So we can write this as integral 1 by root of 1 minus x square dx plus, come on, integral 2 by root of 1 plus x square dx. This 2 is again constant. Letters and numbers are constant. Constant into function, we have to write constant outside. And what is this formula? See, observe your formula list. It is sine inverse x plus, we are writing 2 outside, by root of 1 plus x square dx. Direct problem, isn't it? This one also direct problem. Sometimes problems will not be in our standard form. In such cases, we will reduce that problem into our standard form. So is equal to, it is sine inverse x plus 2. This is a sine h inverse x plus c. Remember, plus c should be there. So after completing, after taking all the values, all the formulas, right, at the end we have to write plus c. Now come to the third one. What is your third question? Integral sine square x, right? Sine square x by 1 plus cos 2x dx. So there is no direct formula for this. So try to convert into our standard form. So first year knowledge, you know that cos 2 theta, we are having the formula 2 cos square theta minus 1. Bring that 1 this side. What happens? 1 plus cos 2 theta is equal to 2 cos square theta. Here theta is there. Instead of theta we are having x. 1 plus cos 2 theta is 2 cos square theta. 1 plus cos 2x is nothing but 2 cos square x. That is in terms of theta, general form. Instead of theta, we can have any value. Formulas means they will be in general form. Instead of that, we can have any other value. Instead of the theta, we can get any value. So 1 plus cos 2 theta always is equals to 2 cos square theta. So 1 plus cos 2x. Now values are in terms of x. So it is 2 cos square x. So is equal to sin square x by 2 cos square x dx. This is sin square, this is cos square. So come on, we will write by using identity sin square as 1 minus cos square x by 2 cos square x into dx. Okay, so observe, this is of the form a minus b by c form is equal to a by c minus b by c. Can we write? Definitely we can write. So you consider this as a minus b by c form, a by c minus b by c, writing separately. So it is 1 by 2 cos square x minus cos square x by 2 cos square x into dx. Cos square x cancel. So inside the integral minus sign is there. Whenever inside the integral plus minus, we have to take the separate integrals. I think slowly you are getting used to the formulas and you are enjoying the integration. Very nice topic. So 1 by cos square x dx minus, come on, here 1 by 2 will be there, only 1 will be there, 1 into dx is dx. So is equal to 1 by 2. 1 by cos is secant, but 1 by cos square is there. So it is secant square x dx minus 1 by 2. This is first formula. Integral dx is x. So is equal to 1 by 2. Come on. Integral secant square x dx. See, actually problem is given like this. We don't have any direct standard formula for that problem. But slowly we simplified by using our trigonometric formulas. At the end, if you observe, we got into our standard form. Integral secant square x dx formula is there in integrals. Integral dx is also formula there in our integrals. Getting my point? So sometimes problem, if we split it directly, it will be in our standard form. Sometimes it will not be in the standard form, but by using our formulas we can reduce into standard form. Okay, so here we have taken 1 plus cos 2x as 2 cos square x. So here cos is there, so try to convert this also in terms of cos. So how we can convert? By using our identity, right? We can write sin square x as 1 minus cos square x. Actually our aim is to convert the problem in terms of cos only, entire problem in terms of cos. That's why we have taken sin square form 1 minus cos square x. Okay, so come on, integral secant square x is nothing but tan x, it is direct standard formula, minus 1 by 2x. Once integration completed, come on, what we have to write? Plus c. This is most important. Okay, so this is your third question. Now come to the fourth question. What is your fourth question? Find or evaluate the integral 1 plus sin square x by 1 plus cos 2x dx. So don't worry by seeing the problem like this. Don't get scared by seeing the problem like this. Just if it is not in our standard form, we will convert it into our standard form. So now only we used, what is this? 1 plus cos 2x is 2 cos square x. So come on, we will write 1 plus cos 2x. So upward it is 1 plus sin square x, and this 1 plus cos 2x can be taken as 1 plus cos 2x we have taken as 2 cos square x. So here also we will take 2 cos square x. It is a standard formula, right? So now downwards we are having cos square, upwards we are having sin square. So upwards also try to get your in terms of cos value. So how we can take 1 plus, come on, instead of sin square we can write 1 minus cos square x, right, by 2 cos square x dx. Okay, so 1 plus 1, 2, 2 minus cos square x by 2 cos square x dx. So again it is of the form, which form? A minus b by c is equal to a by c minus b by c. Upwards if we have two terms, right, and in between plus minus is there, then we can write them in two separated terms. A minus b by c can be taken as a by c minus b by c. So same thing here also is equal to, come on, first 2 by 2 cos square x dx minus, come on, integral of cos square x by 2 cos square x dx. So here cos square cancel, here 2 cancel. So 1 by cos is secant, so but 1 by cos square is there, so secant square. So integral secant square x dx, right, minus 1 by 2 is a number, we will write outside. So only leftover value is dx. 1 into dx is dx. And see how nicely we got into our normal standard form. So integral secant square x dx is nothing but tan x minus 1 by 2. Integral dx is x. See how many times. So now only you got all the formulas, isn't it? So tan x minus half into integral dx is x. After completing the value we have to write plus c. Okay, so now come to the sixth question. What is your sixth question? See the sixth question. Read the question, it is on the board. So it is sixth one or fifth one? We have to do fifth one, then we have to go for sixth one. See the fifth one, secant square x into cosecant square x dx. So is there any direct formula for secant square x into is there? If it is plus, we can write easily. We can take separately and we can apply, that will be in our standard form. But here into is there, secant square x into cosecant square is there. So I said whenever it is not in our standard form, try to reduce into our standard form. So how we can reduce this problem into our standard form? So observe, it is secant square. You know it. Secant and cos are reciprocal to each other. So it is 1 by cos square x. Instead of secant square x, we can write 1 by cos square x. Similarly, cosecant and sin are reciprocal to each other. Cosecant square can be taken as 1 by sin square x, isn't it, into dx is equal to integral upwards 1 into 1, 1 only, downwards it is cos square x into sin square x into dx. So till now it is not in our standard form. So we have to get into our standard form. How we will get it? Downward value is in terms of cos square x, sin square x, and upward we are having 1. So by using 1 we can write identity formula. What is our identity formula? Sin square x plus cos square x divided by cos square x into sin square x, isn't it? Your 1 is by our trigonometric identities, 1 can be taken as sin square x plus cos square x. Again it is of the form a plus b by c, isn't it? So a plus b by c can be taken as a by c plus b by c. Upwards two terms are there, in between plus minus is there, we can write separately. So here also we can write separately. See how nicely the problem is coming. Sin square x by cos square x into sin square x dx. We are taking separate integrals, right? We can write separately. So whenever two terms are there inside the integral, we can take individual integrations. So is equal to cos square x by cos square x into sin square x dx. Come on, cos square cancels. Here sin square cancel. Is equal to integral 1 by cos square x. 1 by cos is secant. So square means it is secant square x dx plus 1 by sin is cosec. But 1 by sin square is there. So it is cosecant square or cosec square x dx. Both are direct formulas. So see the question girls, actually into is there. We don't have any direct formula when they are in multiplication form. But when they are in addition form, we can write separately. And this is your standard integral formula. This is also standard integral formula. You can easily get your answer. So is equal to, this is your tan x and this is your minus cot x plus c. That is the answer. So after getting the values, we have to write plus c. Then only you will get your 2 out of 2 marks. Okay. So always remember, if the problem is in direct form, standard form, then no problem. Directly do it. Suppose it is not in direct form, just reduce it into our standard form. Standard form means reduce into any one of our integral formulae form. See, at the end we got like this. This is standard formula. This is also standard formula. Even here also, see, we got into standard form. We got into standard form in standard formula form, so that we can take the value. After taking the value, you have to write plus c. Okay, now come to the sixth question. What is your sixth question? Observe carefully. Is it direct or indirect? And the question contains two terms or one term. Observe. Suppose two terms, three terms, in between plus minus, we can take separate integral values. Individual integral values. Just like in the derivatives, I will say take the individual derivatives, take the separate derivatives. Same thing here also. Whenever plus minus is there, we can go for separate integrals. Okay. So come on, come to the sixth question. What is that? Integral 1 by 1 minus x square plus 1 by 1 plus x square into dx. So observe, these are the two terms. In between plus is there. Whenever 2, 3 or 4, how many terms? We can have any number of terms, but in the middle of the terms plus minus sign is there. Take the separate integrals. So is equal to integral 1 by 1 minus x square dx plus integral 1 by 1 plus x square dx. Direct formula, it is tan h inverse x plus, it is, I said, most repeated formula in trigonometry. Is it trigonometry? In integration, tan inverse x plus c. This is tan h inverse. Minute difference is there. Tan h inverse, that is tan inverse. Okay. So direct standard formula. So this is your 2 marks question. Okay. So we did 6 problems. Okay. So first question, if you observe, what is that? X plus 4 by 1 plus x square dx. So whenever two terms are there, in the middle plus is there, we have to take the individual integration, separate integration. So integral x plus integral 4 by 1 plus x square. Whenever constant is there with the function, we have to write that constant outside. After that, both will be in your standard formula form. Now come to the second question. Again same thing. if you observe inside the integral, we are having two terms. Whenever like that and plus is there in between the two terms, so we can take the separate integrals. First one directly it is formula form, and second one 2 by root of 1 plus x square is there. 2 is a number. Numbers and letters are said to be constants. Whenever constant is there with the function, isn't it? It is 2 by root of 1 plus x square dx. So it is a constant. Whenever constant is there with the function, with the value, you have to write that constant outside and check the values, right? So integral 1 by root of 1 plus x square dx. Again it is in your standard form. So first two questions are direct questions, and come to the third and fourth and fifth. Those three are little bit indirect problems. Indirect means they are not in our standard formula form. So we have to reduce them into standard form. Okay, if they are not in our formula form, we have to reduce into our formula form. How we can reduce? By using our trigonometric formulas. So here and here we used one formula. It is by your first year knowledge again, right? Cos 2 theta is equal to, based on this formula, what is it? Cos 2 theta is equal to 2 cos square theta minus 1. Bring that minus 1 this side. It is 1 plus cos 2 theta is equal to 2 cos square theta. Okay, so 1 plus cos 2x is nothing but 2 cos square. Instead of theta, right? Instead of theta, we have to take any other value. It is general form, so we can take any other form. Okay, so 1 plus cos 2x is equal to 2 cos square x. We can substitute. So in the downwards it is in terms of cos. So you convert upward also in terms of cos only. How you can convert? So sin square x can be taken as by our identities 1 minus cos square. So entire problem will be in terms of cos. Take separately and do the integration. Okay. Now come to the fifth question. Here suppose in between secant square and cosecant square plus sign is there, then there is no problem. Directly in between two terms plus is there, so we can take the separate integrals and we will find the value. But multiplication is there, isn't it? So here multiplication is there. Suppose plus we can take separately, we will do it. So whenever it is not in our standard form, try to convert it into our standard form. How we convert it? First secant and cos are reciprocal to each other, and cosecant and sine are reciprocal to each other. What is the meaning of reciprocal? We can write secant x as 1 by cos x. We can write cosecant x as 1 by sine x. So secant square means we can write 1 by cos square x. Actually 1 by cos x whole square. So applying square, 1 square is 1 only, 1 by cos square x. Similarly, cosec square x is nothing but 1 by sin x whole square. Taking the square separately, 1 square and sin square. 1 square is 1 only. So it is 1 by sin square x. Okay, so 1 into 1 is 1 only. Multiply these two values. Now downwards we are having cos square x into sin square x, and upwards we are having 1. So by our trigonometric identities, in place of 1 we can substitute sin square x plus cos square x. So now it is of this form, right? A plus b by c form. We can write a by c plus b by c. Two terms are there. So in an integral plus is there between two terms. We can go for separate integrals. So take the separate integrals and cancel them, right? So here sin square cancel, here cos square cancels. So left over is 1 by cos. 1 by cos is secant, but square is there, that's why secant square. 1 by sine is cosecant, square is there, that's why cosecant square. These are standard formulas in our integrals. So slowly we have to get used to these formulas. So this one is tan x. and integral cosec square x is minus cot x plus c. Okay, so and the sixth one is a direct question, right? So just inside the bracket we are having the plus sign. Whenever plus minus, just take the separate integrals, and this is tan h inverse x, this is tan inverse x plus c. Most repeated, most important thing is for each and every answer throughout the chapter till we complete the integration, for each and every problem at the end of the answer you have to write plus c. Actually here tan h inverse x plus c plus tan inverse x plus c will be there. But what is meant by c? It is a constant. If you add constant to constant, again constant. If you deduct the constant minus constant, again constant only. That's why no need to take plus c plus c plus c for each and every term. Only at the end you can write plus c, that is integral constant. Okay, actually while taking the formula I have given for each formula plus c, but here we apply 2-3 formulas. Here plus c will be there, here plus c will be there. Suppose 3 terms, that there also plus c will be added, but no need to take the constant so many times. Why? If you add constant you will get constant only. Even if we deduct constant only, we will get it. So at the end of the answer we have to write only one c, not all. Suppose 3 terms, 3 c's, 2 terms, 2 c's, not like that, right? So you have to write only one c. Remember this point, this is most important. Okay, so practice the problems and try to practice first for a few days, first at least 3-4 days. Try to write the formulas daily so that you will get used to the formulas. Okay, so that's all for today. Have a nice day.